Hello and welcome to the Enterprise Tech Talk podcast, where I aim to discuss key challenges and the new trends within IT industry. In this series, I try to explore key enterprise technology topics, not in complex technical jargons, but using simple business language that is hopefully easy to follow for business and IT audience alike. Okay, the topic of today's podcast is safe and scalable AI adoption for the enterprise from GenAI to agentic autonomy. We are currently navigating the most significant technological inflection point of our careers. We have moved past the novelty of GenAI and now we are facing the hard truth. That is, the transformation is mandatory but not guaranteed. The question is no longer if AI will impact your business, but how you move from isolated experiments to scaled, trusted autonomy. In this podcast, we are going to cut through the hype and provide a blueprint for mastering the shift from passive Gen AI to action oriented agentic AI. We shall cover the technology mandates, the governance imperative, and the crucial ROI framework that you need to justify the massive investment. Let's dive in. Let's start with the benchmarks. Executive commitment to AI is undeniable. A staggering 85% of leaders plan to increase their spending on AI and GenAI this year. Approximately 30 to 40 billion in enterprise spending is focused on GenAI tools and systems. We are seeing rapid adoption across the board. Nearly 78% of organizations now use AI in at least one business function. The fastest growth is currently in IT adoption, which has jumped dramatically. But let's put this investment in perspective. This isn't just small scale funding for pilot projects. Most of the organizations are still busy building AI prototypes. The focus is primarily on improving operational productivity, while the high value growth use cases mostly remain a distant goal. However, the investment figures demonstrate a strategic conviction that AI is the future. This sets the scene for the challenge we face next, translating this massive, undeniable investment into equally massive business returns. But here is the elephant in the room we must discuss the generative AI ROI challenge. Enterprises are spending heavily on AI, yet, according to recent researches from McKinsey and MIT, approximately 80 to 95% of companies have yet to realize significant gains in top line or bottom line performance. Why? Because building a flashy AI prototype is easy, but generating measurable business value is not. Current adoption focuses heavily on horizontal productivity. Like think of making employees marginally faster at general tasks, like summarizing emails or drafting a business document. The small time savings these GenAI tools create often fail to translate into demonstrable system level financial metrics, especially when weighed against high operational costs. The brutal truth is that only 5 to 15% enterprises have realized demonstrable business value from their GenAI efforts. The high value vertical use cases, that is, the processes that actually move the needle, like zero touch claims processing in insurance industry or automated risk detection in trading, these use cases remain stuck in pilot limbo. To unlock that value, we must pivot to the next evolution, and that is agentic AI. What exactly is agentic AI? It is the fundamental evolution from generative AI. Think of it this way. If GenAI is a calculator, then agentic AI is an accountant. The calculator is a passive tool that responds to a prompt. The accountant, on the other hand, is an intelligent system designed to operate independently to achieve predefined specific goal, like closing the quarterly books without constant external intervention. The core difference here is trusted autonomy. An agent is proactive and anticipatory. To execute its mission, an agentic system must be able to do four tasks. One is perceive its environment. Second, the reason through the tasks. Third, the formulate complex multi-step plan. And finally, execute that plan by taking action using enterprise APIs and available tools. The large language model is merely generative. The agentic AI, on the other hand, is generative as well as action oriented. The impact of this shift is profound. Agentic capabilities enable zero-touch operations through multi-agent systems, which are networks of specialized entities that communicate seamlessly. This will fundamentally reshape your organization structure, moving beyond individual co-pilots to hybrid human-machine teams. In the future, a single employee may orchestrate 15 to 20 agents for massive productivity gains. Eventually, advanced business functions will be led by fusion teams, where a small number of staff would manage potentially hundreds of agents, thus unlocking multi-fold increase in productivity. So this is not just about small time savings. It is about a complete re-architecture of work. Key to this model is the agent orchestrator. This is the layer that dynamically allocates resources, prioritizes tasks, and continuously monitors agent performance, ensuring interoperability and minimizing errors after the initial human setup. This operational model must be supported by a foundational governance structure, as you can imagine. This structure must ensure policy adherence, key platforms for enforcing behavior in real time, and oversight for transparency and auditability. To scale successfully, you need a disciplined framework for prioritizing where capital is deployed. I would recommend a three-tiered approach built upon a strategic funding loop. First, we must focus on quick wins, which would deliver immediate productivity improvements, like internal copilots. They are easy to pilot and deploy, often funded under incremental investments, and have a shorter time to value, typically few months or maybe up to a year. Next, we should pivot towards differentiating use cases. These initiatives target competitive advantage by leveraging unique enterprise data within custom applications, like your CRM data, for example. They carry higher risk and cost, but also offer distinct advantages. Think of a custom trained model for detecting specific financial fraud patterns unique to your industry. Time to value in this case is medium, between 1 to 2 years. Lastly, we should aim for transformational initiatives. This is where agentic AI truly shines. The potential to upend markets and business models. These projects have high complexity, unpredictable risks, and a longer time to value, typically 2 years plus. Note here that the quick wins generate the internal capital which is necessary to fund even more complex differentiating and transformational initiatives. For transformational initiatives in particular, the executive investment decisions must prioritize strategic and market level impact over any immediate quantifiable financial returns. A practical example for transformation comes from the manufacturing sector. One enterprise from manufacturing industry, it achieved full-scale transformation by combining analytical AI, Gen AI, and traditional digital tools. This created a closed-loop system where machine vision and sensor data monitor production performance in real time. When the key performance indicators deviated, the system autonomously escalated the issue to the appropriate maintenance agent, often resolving the production bottleneck without human intervention. Measuring AI ROI is different compared to traditional software investments. Its impacts are rarely immediate and often unfold over months, even years. Your measurement framework must extend beyond simple immediate gains. About half of the organizations struggle to estimate and demonstrate the value of their AI projects, making it a bigger challenge than talent shortages, technical issues, or even trust in AI itself. So let's understand the cost factors. Data preparation and platform upgrades typically consume 60 to 80% of any AI project timeline and budget. Yet, most business cases completely ignore this reality. We budget for AI models, for example, but forget about cleaning and organizing your messy data, upgrading systems so AI can actually integrate, training your teams to use AI effectively, ongoing maintenance and model updates, testing, debugging, and fixing edge cases, and so on and so forth. To measure AI impact effectively, we should break ROI into two measures across different time horizons. This allows us to track both short-term progress as well as long-term financial value. In the short term, the focus should be to monitor early indicators that suggest your AI is delivering value, even if it hasn't yet translated into financial metrics. These early indicators could be user adoption, whether employees or users are using AI more frequently, time savings, quality improvements, or even demonstrable quick wins. In the long run, the AI ROI should be tracked under hard and soft metrics. The soft ROI is hidden value. The most critical metric here is where the time saved is reinvested. If time freed up by automation is channeled into innovation or complex problem solving, the soft ROI can significantly improve talent retention and reduce long-term acquisition costs. For example, a report suggests 15% increase in employee satisfaction due to reduced burnout. Tracking this time redeployment is a critical managerial performance indicator. Hard ROI is quantifiable. This includes revenue increase, tracking error reduction, and direct cost savings. For example, AI-driven customer support has been shown to reduce response times by almost 35%. Other key soft and hard agentic ROI metrics include cost per transaction, tracking agent to human handoff rates to understand where autonomous systems fail, um, and decision accuracy rates to ensure the reliability of autonomous actions. As organizations embrace agentic AI, the systems that can reason, decide, and act autonomously, the real competitive advantage won't come from the AI models themselves, but from the data backbone that supports them. Agentic AI needs real-time, accurate, and trusted data to operate responsibly. That means building a foundation that delivers low latency, high accuracy, and zero hallucinations. At its core, this data backbone combines a real-time streaming layer, which is powered by technologies like Kafka for instant data flow, then a governed data lake for accuracy and consistency, and a semantic layer with vector and knowledge graph technology capabilities that explicitly model relationships between entities, like connecting a customer record to a recent transaction and to a risk score. This rich context is crucial for multi-step reasoning to give AI agents context and meaning, not just data. Another agentic AI pattern, called retrieval augmented generation or RAG, becomes the guardrail, ensuring every AI action is grounded in authoritative enterprise information, not guesswork. And metadata, lineage, and policy controls ensure transparency, compliance, and explainability. Furthermore, agents interact with large datasets in secure, well-defined APIs. You must adopt an API first data access strategy, treating every data interaction as a programmable tool for the agents, ensuring that access is fast, reliable, and secured by agent identity management controls, something that we will discuss on the next slide. The result is a living data fabric that enables agents to act confidently and responsibly, responding in milliseconds and grounded in truth and fully auditable. In short, before we can trust agentic AI to act, we must trust the data backbone that guides it. Enterprises that build this foundation will lead in safe and scalable and value driven AI adoption. Agentic AI systems, by acting and planning autonomously, fundamentally break the predictability upon which the traditional cybersecurity relies. They expand the attack surface drastically, exposing organizations to new high stakes threats such as prompt injection, where attackers manipulate prompts to trick models into disclosing sensitive business information or cache data. Impersonation, where malicious agents exploit the same applications and interfaces that authentic agents use, and memory poisoning and privilege compromise, and so on and so forth. Importantly, because an agent acts as a fully privileged actor, managing agent identity is paramount. If an agent's identity is compromised, the breach could be catastrophic. An agent has the programmatic ability to move across platforms, delete system files, and exfiltrate data at machine speed, turning a small security incident into an enterprise-wide disaster. Agents must be treated like highly privileged individual employees, each requiring a unique, verifiable identity and fine-grained access control based on principles of least privilege. So to enable this, security must evolve from a defensive function to a strategic enabler of trusted autonomy with a multi-tiered approach. One is deploying real-time guardrails to evaluate prompts, responses, and planned actions before those are executed. These guardrails can block prompt injection, detect policy violations, and enforce tool access restrictions. Second is adopting emerging frameworks that propose separating a privileged LLM for trusted commands from a quarantined LLM, which has no memory access or action capabilities. And finally, continuously test defenses by simulating realistic attacks, including privilege abuse and indirect prompt injection. The enterprise architecture for agentic AI is still maturing. However, we can already see how it would operate under a few distinct layers. First is the foundational layer, or the data backbone. This is the engine room. It's defined by the technology mandates we are already discussed, such as the real-time data streams, cloud native, low latency data lakes, and critically the information graphs. The goal here is to provide a unified, structured, and a fast source of truth that agents can trust. Second layer is the orchestration layer, or the brain. This is the governance and intelligence hub. It hosts the main agent orchestrators, which manage the task allocation, as well as the guardian managers, which enforce security policies and ethical guidelines before actions are taken. This layer is responsible for the overall reasoning and adherence to policy. And third, the execution layer, or the hands. This is where the agents actually operate. It includes the agent identity manager for access control and API service gateway, the gatekeeper to data access. All agent interactions with enterprise tools, the databases, or even external systems must pass through these security mandates to verify agent's identity and check its privileges against the principle of least privilege before any action is executed. Adopting this layered approach ensures that security and governance are inherent parts of the architecture, not just an afterthought. As autonomous agents begin making independent decisions, accountability cannot be allowed to vanish. Your governance frameworks must be augmented to handle this risk. Governance is the structure that ensures agents operate safely, ethically, and within regulatory boundaries, even at machine speed. Without it, autonomy quickly becomes anarchy. So, how do we build trust with the agentic systems? Trust is achieved through transparency, traceability, and control, which requires embedding governance into the orchestration layer itself. Uh, One of the critical dimensions of governance for autonomous system is data privacy and legal compliance. As agents consume and generate data, they must strictly adhere to regulations like GDPR, CCPA, Privacy Act in Australia, or HIPAA in US healthcare sector. For example, imagine a diagnostic agent in a hospital. If this agent is trained on protected health information and then uses that data to generate an output or make a decision, your governance framework must guarantee that the protected health information is fully anonymized or de-identified before model training. Also, the agent's outputs cannot be used to re-identify an individual. And also, the audit logs clearly demonstrate that the data never cross regional or regulatory boundaries. Any legal breach, especially in regulated fields like healthcare, can result in massive fines and loss of public trust. Therefore, governance must mandate a privacy by design approach, ensuring legal and privacy requirements are baked into the agent's architecture itself, not bolted on afterward. For ethical design, you must deliberately question the necessity of creating overly human-like agentic AI systems. Nearly 80% of experts agree that responsible AI governance requires a context-dependent approach. Your framework should mandate an analysis to determine if features like apparent humanness serve a practical and beneficial purpose, ensuring the benefits clearly outweigh the considerable associated risks before proceeding with deployment. The shift to GenAI and agentic AI requires a systemic program for workforce upskilling. The data shows this is already happening. 75% of global knowledge workers are already using AI at work. AI aptitude could soon rival traditional experience as a critical career criteria. For large enterprises, the training programs need to address two areas or two cohorts. One is for general end users who need foundational skills in standard prompt engineering techniques like chain of thought for accurate LLM interactions. The second specific cohort is engineers and developers who need to master agentic prompt engineering. This is the advanced skill of using prompts not just to retrieve information, but to guide autonomous agents in making decisions, planning, and taking actions based on structured input. Now, with increasing complexity in managing multi-agent systems, slowly a new role is emerging within the enterprise. It's called agent orchestrator. It's an employee who manages and secures the multi-agent fusion team model. Now, this is the new leader of the automated enterprise who would manage a team of AI agents, ensuring collaboration between the agents, providing high-level strategy and direction to the AI team, and assisting in integrating AI agents into the existing business process. So, what are the key takeaways? The era of simple GenAI experimentation is over. To address the ROI challenge and prepare for agentic autonomy, senior leaders must demand immediate action in three non-negotiable areas. The first one is refactor the technology backbone. This should focus on investing substantially in low latency cloud native data pipelines and data lakes with adequate data governance guardrails, bringing context to data by leveraging technologies such as vector and knowledge graphs, architecting multi-agent AI systems by deploying orchestrator and policy agents, which act only as coordinators and implement immutable logs for auditability, and securing AI agent systems with least access privilege principles. The second area is operationalize the ROI loop. Uh, the focus here should be adopting the three-tiered prioritization framework that we discussed earlier, which is quick wins, then differentiating use cases, and then transformational use cases. Mandating the tracking of employee time redeployment as a key soft ROI metric, ensuring efficiency gains are channeled directly into innovation. And also, importantly, implementing KPIs that measure autonomous outcomes, such as agent to human head of rates or the decision accuracy rates, and so on and so forth. And the third non-negotiable area is about autonomy and governance. Uh, Here, the focus should be shifting security from defensive to strategic enabler of trusted autonomy, implementing adaptive context-aware controls, enforcing strict input validation, and securing agents against threats like memory poisoning, and then prioritizing real-time guardrails and LLM separation to mitigate catastrophic risks such as prompt injection and data exfiltration. The adoption of agentic AI is a strategic requirement. It demands more than just technology procurement. It requires a reframed strategy, a modernized backbone, and a profound commitment to a trusted autonomy. We covered a lot today. So, to summarize, we are standing at the threshold of a new era, one where intelligent agents will not just execute commands, but make decisions that shape outcomes. The winners in this next wave won't be those who experiment first, but those who build trust first. Because before you can trust AI to act, you must trust the data, governance, and strategy that guide it. I would leave you with a final note. The future of AI isn't about what machines can do. It's about what your enterprise dares to trust them to do. Thank you for listening to this podcast. Hope you found it useful. If you want to discuss this topic further, please feel free to reach out to me on LinkedIn. Have a great day.